Hello everyone, and welcome to this example recording on super meshes, where we're going to be using mesh analysis to determine the currents I1, I2, and I3. So as per the previous example, you know that when you are looking at your super mesh analysis method, the first step is to remove the current source forming the super mesh and any element connected in series with it, and then you're going to do a mesh analysis in the circuit that remains. So what we have remaining would be the following circuit. This will be 8, that's 4, this is 2, that's 2, and that's 6 volts. And the current flowing here is, we know it's going to be, this current is going to be I1, we know that current is I3, and the current here is I2. Right, so if we do a KVL in the super mesh, then what we're going to find is we're going to find negative 6 volts plus 2, so this 2 multiplied by I1 minus I3 plus 4 multiplied by I2 minus I3, so we're in this super mesh, I2 minus I3 because we're working in the super mesh, plus 8 times I2 gives you 0. And if we simplify this, we're going to find that you've got 2I1, and then you have I2 plus 4I2. And then in terms of I3, you've got it's 8I2 plus 4I2. This is actually 12I2. So it's the 4I2 plus 8I2 gives you 12I2. Then in terms of I3, you've got minus 2I3 and you've got minus 4I3, which gives you negative 6I3, and all of this is going to give you 6, and that's the first equation. The second equation would be KVL in loop 3 or mesh 3. Okay, and for us to then have that expression, we will just do a KVL at that point. So it will be 2I3 minus I1, that resistor there, plus 2, this resistor here, I3, plus 4, I3 minus I2 gives you 0. And if we simplify this, we're going to find minus 2I1, and we're going to find minus 4I2. Then we've got 2I3 plus another 2I3 gives you 6I3 plus another 4I3. It's going to be plus 10I3 gives us 0, and that's our second equation. Now our third equation yet again would be us determining a point where we can do a KCL where the source is connected. So there's the source. We can do a KCL either at that point or at that point. The question is though, which point is simpler? Right, if I do a KCL at this point, the current that's flowing in this branch and that branch is not a single current. It would be a mesh of the different currents. So for example, the current flowing here would be a combination of I3 and I2. The current flowing here will be a combination of I1 and I3. So this will not necessarily be the best place to do this KCL. Whereas if I do it here, I'm going to say the current going down here is 3, and the current going in here is I2. The current going out there is I1. So therefore I can say KCL ground node. I can say that I2 plus 3 is equals to I1. And we can simplify this by then saying that 3 is equals to I1 minus I2. And this will be our third equation. Since the equation has 3 unknowns, as you can see, 3 variables, we can also just standardize this one and we can say plus 0 I3. And this will be our third equation. Then we solve this. So we're going to select equation mode. So 5, this time we select the quadratic function, number 2, and we put in our coefficients. First set of coefficients, 2, 12, minus 6, and 6. So it will be 2, 12, minus 6, and 6. The second set of coefficients will be minus 2, minus 4, 10, and 0. So minus 2, minus 4, 10, and 0. And the final set of coefficients will be 1, minus 1, 0, and 3. So 1, minus 1, 0, and 3. Let me just double check all of those. So you've got 12 minus 6. So you've got 2, 12, minus 6, and 6. You've got minus 2, 4, 10, and 0. And you've got 1, minus 1, 0, and 3. Right, and let's take a look at what that will give us. So we find a value of I1 is 3.3 amps. We find a value for I2 as 0.346 amps. And we find a value for I3 as 0.807 amps. Right, and that is the currents I1, I2, and I3 using mesh analysis to determine the currents. Thank you for watching this video and enjoy the course.